Hi, I'm Elizabeth Crisfield. I'm a consultant working primarily with state agencies to support biodiversity conservation. Today, I'm going to give you the intro presentation for this segment of the workshop on trait databases. We'll be drawing on experience that others have working with databases for different taxonomic groups. So I'm going to focus my introductory talk generally on what a trait database is, but also what it might look like for native bees and how it could help us. So I've organized the talk around these three questions. What is a trait database? How would a trait database be used in the bee conservation community? And why is it important to have one? So there are many things that could be in a trait database, and I'm just basically providing a conversation starter here. Obviously, there are the physical traits that can be measured that are used both for identification of species and for understanding advantages and vulnerabilities. That leads us to the next kind of trait, which are the unique behaviors and life history considerations. And then there's the possibility of describing the range or distribution of the species in addition. And now each of these types of traits have very different uses, and I'm going to get more into that in a second. But first, here are some obvious examples of the kinds of traits that would fall into those categories. So on the right, we have the physical measurements that allow us to identify and classify bees. But these are also things that help us understand how the bee interacts with its environment. So it's sort of dual purpose there. On the left, we have traits that explain how bees relate to other biotic components of their environment and some of the life history details that can help reveal either specialization and maybe vulnerability or generalist strategies that might mean the bee is more resilient. And I'm going to approach the question of what should be in a bee trait database by considering the diversity of uses of the database, and then we'll revisit this slide toward the end. So, how would a trait database for native bees be used? The first answer is to simply science, right? A place to record a growing body of knowledge. The most experienced researchers among us have developed an incredible, like almost intuition about bee species based on decades of observation. But while some specialists in identification know a tremendous amount about the physical characteristics, others know more about habitat and floral resource associations. Some people specialize in understanding soil nesting, while others might have information about vulnerabilities to disease or pesticides. So sharing this information between people of different expertise is certain to result in new understandings of everything from evolution and classification to habitat requirements, symbiotic relationships, and life cycles. So this database could become the scientific record for the community, making the expansive knowledge more accessible and digestible for more people. But to get back on my own home turf, another use of the data set and a way to decide which traits we want to include is to consider threats to bees that we want to be able to understand and address. This graphic is from the UN Environment Program. It communicates some commonly assigned threats to bees, air pollution and pesticides, which have a wide range of mechanisms through which they can negatively impact bee populations. But there's also habitat degradation, climate change, disease, and other threats that may be affecting bees. So we could prioritize traits in the database to help us understand the vulnerability of different species to these threats. And then another way to do it would be to decide what needs to be done to mitigate the threats so we can consider the conservation actions we want to take. And then we can increase the certainty that those actions will be effective if the traits database could show specifically why the species is vulnerable to the threat and how the action would minimize that threat impact. So for example, the common best practice now of leaving standing dead snags and downed wood on a site after forestry management provides nesting substrate for cavity nesting bees, for example. But there was a time, decades ago, when we didn't really know about the nesting needs of these species, and we would clean up a site like we clean up the living room, you know? So what more could we learn about best practices if we had a trait database? So possibly the most obvious example of all, which bee species have strong associations with plant species? The information we already have on this topic has led to some of the most robust conservation guidance we can provide at this time. We can say plant this because these species need the pollen, or plant this, this, and this, and that will provide a food source throughout the growing season and support a greater diversity of species. Or plant specifically this native species because, and this bee, where this bee is found, and because they need each other. So we need to provide more specific guidance, but the reality is that it is hard to provide confident advice based on just a couple of studies, and none of us has time to do the massive meta study we would need to do. So the database could fill that need. Okay, habitat associations and detailed physical requirements in a trait database could lead to reliable habitat suitability models. The models would help us better project conservation needs, especially with climate change. They may also lead to finding new populations of rare or imperiled species. They could also provide better habitat management guidance. And monitoring. And dispersal distances are hypothesized to be related to bee size, but a database could help refine those ideas. Where pesticides are a substantial threat, understanding dispersal distances could help define protection areas. Dispersal distances are also important to understand when planning significant habitat management activities, like can bees recolonize a site from adjacent control plots, for example. Dispersal distances are needed to understand the degree to which populations are isolated. So a database that could provide dispersal distances for different species could help with all of those things. And then there's monitoring. Determining presence and absence, population status and trends, comparing data between sites. All of this requires us to develop consistency in our monitoring approaches, which is one of the premises of this RCN effort. But we know that there are biases between methods for different species, and also that early spring and late fall bees are underrepresented in the existing data sets. So we could learn how to better detect the rarest bees by looking at a trait database. We can include traps that have detected the species, date ranges when the species has been observed, target habitats or flowers where the species has been documented. So here's the slide I showed when talking about what a bee trait database might include. Most of my work involves conservation action, so my examples of potential uses were a little skewed in that direction. But clearly we have opportunities to advance the understanding of bee evolution and classification, the science side, and we can improve monitoring strategies to help us find rare species and possibly determine that they might be secure. We would have many factors relating to forage from floral resources, and we would have others that relate to physical resources unique to habitat types and ecoregions. So to conclude, I hope I've demonstrated how valuable a trait database could be for our community. I focused on 3 types of uses in this presentation: the foundational research, applied science, and monitoring techniques. The trait database is important for the advancement of science as we work collectively to fill data gaps and understand bee biology and ecology better. And then it's important as we apply that scientific understanding to the conservation of the diversity of bees. In that regard, it can also serve as the foundation of accurate and precise communication of conservation strategies for the wide range of land managers. And finally, the trait database will benefit from an enhanced monitoring program, but it would also help us develop a more robust and effective monitoring program. So thanks a lot for listening. I'm really looking forward to the next set of talks to give us some more ideas about how this could actually come to be.